everyone. Welcome back for another deep dive.
Always a pleasure.
Today, we're going to be looking at something I found super interesting.
Oh, yeah.
It's a paper called How Complex Systems Fail by a Dr. Richard Cook. And it was written back in 1998.
Wow, way back then.
But it feels so relevant even now with everything being so interconnected.
Yeah, true. That's interesting.
Yeah, and so Cook, he lays out this framework for how accidents can happen.
Okay.
Even in systems that are really sophisticated,
Makes sense.
And it really makes you think differently about how we view safety and risk.
I can see that.
Yeah, all these systems we use every day, like transportation or healthcare,
Right.
even financial systems.
Sure.
They might not be as foolproof as we think,
Yeah, I get that.
So I was hoping for this deep dive we could really break down Cook's ideas
Okay.
and see what it tells us about, the hidden risks that are all around us.
Sounds good to me. Where should we start?
Well, Cook starts off with this pretty bold statement. He says that complex systems are just inherently hazardous.
Oh, wow.
Yeah, he argues that it's not a question of if they'll fail, but when they'll fail. And that's because these systems have so many parts all working together.
Right.
You've got the tech, the human operators, the whole structure of the organization.
Yeah.
And that complexity makes it almost inevitable that something unexpected will happen.
Interesting.
Yeah. I mean, even with the best engineering and safety protocols you can think of,
Right.
there's always a chance that something will go wrong.
That's true.
Think about the Challenger disaster.
Oh, wow. Yeah.
There were all these technical problems, warning signs that people kind of ignored or dismissed.
Right.
Little things that seemed small at the time, but they added up to this catastrophic failure.
It's crazy how that happens.
Yeah, so it's not enough to just prevent individual errors. You have to understand how those errors can interact and make each other worse.
I see.
Yeah, and Cook uses this analogy of Swiss cheese to explain it.
Swiss cheese.
Yeah, so imagine each slice of cheese is a layer of defense in the system. And the holes in the cheese, those are the potential failures.
Got it.
Most of the time, those holes don't line up right, so the defenses work.
Right.
But sometimes those holes line up perfectly, and that's when an accident happens.
Wow, that's a good way to picture it.
Yeah, it's kind of scary when you think about it.
It is.
But if these little failures are happening all the time, why don't we see more accidents?
That's where the idea of degraded mode comes in.
Degraded mode? What's that?
It means that complex systems are often running with hidden problems, like little things that are broken but you don't really notice.
Okay.
Like a ship slowly taking on water. It might seem okay, but there's a problem underneath. And what's scary is that this degraded mode can become normal.
How so?
People start accepting these little workarounds, these temporary fixes,
Right.
and that can make everyone complacent.
So we've got these complex systems running in this degraded mode with all these hidden problems.
Yeah.
But the people running these systems, the experts, they must know about the risks, right?
Well, that's where things get really interesting.
Okay.
Cook argues that the people operating these systems, they actually have two roles.
Two roles.
They're both producing the system's output, making it work,
Right.
but they're also the ones defending against failures.
Huh.
They're constantly trying to balance these two things, keeping the system running smoothly,
Okay.
but also trying to prevent accidents from happening.
So it's like they're walking a tightrope,
Yeah, exactly.
trying to hit their production goals, but also stay safe.
Right, and that pressure can be intense.
Especially in industries where safety and efficiency are always bumping heads.
Absolutely.
So are we really expecting operators to catch every single problem?
It's a good question.
Especially with all this complexity and uncertainty.
Yeah, Cook points out that every action an operator takes is basically a gamble.
A gamble.
They never have all the information,
Right.
and the outcome is never certain.
That's tough.
And that brings us to another important idea. Hindsight bias.
Hindsight bias.
It's like when we look back at an accident and say, oh, they should have seen that coming.
Yeah.
But at the time, those operators might not have had all the information.
Right.
Or they were dealing with a bunch of other things.
Makes sense. It's like Monday morning quarterbacking.
Exactly.
Cook says we need to be careful about judging operators based on what we know after the fact.
I agree.
We need to try to understand why they made those decisions, what information they had,
Absolutely.
and what pressures they were under.
Right.
So we've got these complex systems running in degraded mode
Yeah.
with human operators making these tough decisions under a lot of pressure.
It can be a recipe for disaster.
It sounds like it.
But Cook also points out that human operators are incredibly adaptable.
In what way?
They're always making adjustments, finding workarounds, basically keeping the system running even when things are tough.
So it's their expertise and experience that helps prevent more accidents.
Exactly, and that's something we'll explore more in part 2 of this deep dive.
Okay.
We'll look at how expertise develops, how it's passed on, and why it's so important for the safe operation of these complex systems.
Looking forward to it.
It's amazing, isn't it, how operators are making those crucial decisions in these complex systems.
Yeah, for sure. Their expertise is what often prevents a near miss from turning into a disaster.
Exactly, but how does that kind of expertise even develop?
Right. Is it just about time on the job, or is there something more to it?
Experience is key, of course. Cook emphasizes that true expertise comes from encountering and understanding failures.
So you're saying it's not just knowing the textbook version of how the system works?
Not at all.
Yeah.
It's about knowing how things behave when they're pushed to the edge, when they start to break down.
I see. So it's like knowing where those unpredictable points are.
Precisely, like imagine a test pilot pushing a new aircraft to its limits.
Okay.
They have to experience those edge-of-the-envelope moments to know how the aircraft will react.
That's intense.
It is, and it helps them understand what to do to stay in control.
So how do you create an environment where operators can learn from those situations safely?
Well, you can't exactly tell them to experiment with a nuclear power plant.
Right. Of course not.
But simulations and training exercises can be really valuable.
Ah, I see.
They let operators experience those high-pressure scenarios without actually putting the real system at risk.
So they can get that experience without the danger.
Exactly. And these training scenarios shouldn't just focus on what to do when everything's going right.
Okay.
They also need to learn how to handle things when they go wrong.
It's like building that instinctual response to pressure.
Exactly. And Cook even suggests letting operators push boundaries in a safe environment during training.
You mean let them get close to those near-failure situations?
Yeah, so they can develop those recovery skills.
That's interesting, but there are limits to what you can simulate, right?
Of course, real-world situations are always going to have surprises.
So what else can be done?
Well, it's also about creating a culture of learning and continuous improvement.
So that operators feel comfortable sharing what they've learned, both the good and the bad.
Exactly, and that way the whole organization can benefit from those experiences.
And that brings up the importance of communication in these systems.
Absolutely. If operators aren't talking to each other or to management about potential problems,
Right. Then those small failures can easily become big ones.
you got it. Open communication is crucial for preventing those hidden failures from piling up.
This is all really insightful, but I'm curious how expertise is changing with technology.
That's a great question.
Are the skills needed to operate something like a nuclear power plant today the same as they were decades ago?
It's a tough one. I'd say yes and no.
How so?
The basic principles might be similar,
Okay.
but the tools and technologies have changed drastically.
So the skills required have also shifted.
Exactly. It's less about manual control now
Okay.
and more about monitoring, diagnosing, and making strategic decisions.
So are you saying operators need to be more tech savvy now?
In a way, yeah, they need to interpret data, troubleshoot software, maybe even interact with AI.
Wow, that's a lot different from just flipping switches and checking gauges.
And this shift toward automation raises new questions about the future of expertise.
Will we even need human operators in the future?
A lot of people are wondering that.
It's tempting to think technology will eliminate human error.
But Cook's work suggests it's not that simple.
So there will always be those unforeseen situations, those circumstances that need human judgment.
Exactly. It's that adaptability that makes human operators so valuable.
It highlights the need to keep investing in training and development, even with all these advancements.
Absolutely. We need to ensure operators have the skills to handle these increasingly complex systems.
To see the risks and make good decisions when things go wrong.
Right. And that makes me think about how we pass on that expertise to the next generation.
It's crucial for these systems to be safe and resilient, right?
Absolutely. We need to find ways to capture all that knowledge and experience so it doesn't disappear when people retire.
So it's not just about individual training, it's about creating a kind of organizational memory.
Precisely, making sure that expertise is built into the system itself.
So maybe using new training methods, mentorship programs, even technology to share that expert knowledge.
All of that, yeah.
We've covered a lot of ground here, from the nature of expertise to the challenges of training.
We have.
How does this all tie back to safety as an emergent property?
That's a great transition. Let's explore how fostering a culture of safety, embracing continuous learning, and understanding the limits of both technology and human operators contribute to making systems more resilient.
We've talked a lot about expertise and training, but it seems like it's just one piece of the puzzle when it comes to safety.
Yeah, it's bigger than that.
So Cook is pushing for a more holistic approach, right?
Exactly. He keeps coming back to that idea of safety as an emergent property.
Right.
It means you can't just tack on safety measures at the end. It has to come from the whole culture, the design, the way people interact with the system.
So it's not just about having the right technology or the right training.
Yep.
It's about creating an environment where safety comes first for everyone.
Exactly. It's about people feeling like they can speak up about problems.
Yeah, okay.
Where learning from mistakes is encouraged and everyone knows their role in keeping things safe.
That makes sense. But how do you actually create that kind of culture?
It's tough, especially in places that don't like change.
Yeah.
It takes a shift in how people think.
Okay.
You have to move away from blaming individuals when things go wrong.
Right.
And focus on the systemic factors that contributed to the failure.
So instead of asking who messed up,
Yeah,
we should be asking, what can we learn from this?
exactly. And that learning needs to be continuous.
So it's not just about investigating accidents after they happen.
Right.
It's about constantly monitoring the system, looking for those little warning signs.
Exactly. Those near misses that might be hinting at a bigger problem.
It sounds like it takes a lot of humility, too.
Yeah,
Admitting that even the best systems can fail and that we're always learning.
I think that's key. We can't eliminate all risk,
Right.
but we can build systems that are resilient, that can adapt and learn from mistakes.
It reminds me of that tension between efficiency and safety.
Oh yeah, that's always there.
There's always pressure to do more faster, cheaper.
Right, to streamline everything.
But if we sacrifice safety, we're setting ourselves up for failure.
Absolutely.
But-
It's a balancing act for sure.
Yeah.
But Cook gives us a framework for managing that tension.
Okay.
It's about understanding that safety isn't something you compromise on.
Right.
It's essential for long-term success.
This has been a really eye-opening conversation.
It has.
But I'm still wondering how to apply these ideas to my own life.
That's fair enough.
I mean, I'm not running a nuclear power plant or anything.
But think about all the complex systems you interact with every day.
Okay.
Transportation, healthcare, the internet, even your workplace.
I guess I am starting to see those systems differently now.
Yeah.
I'm more aware of how things can go wrong and how important those small warning signs are.
That's a great start. And remember, you're not just a passive observer.
Okay.
You can make those systems safer, too.
How so?
It could be as simple as speaking up when you see something off.
Right.
Or being more careful about your own actions within those systems.
It's empowering to think we can actually make these systems more resilient and safe.
It really is.
Yeah.
So as we wrap up this deep dive, I want to leave you with this.
Okay.
Next time you see a system failure, big or small,
Yeah.
don't just blame someone and move on.
Okay.
Take a minute to think about what caused it, what factors contributed,
Right.
and what lessons can be learned to prevent it from happening again.
That's great advice. I know I'll be looking at the world a little differently now,
I hope so.
and hopefully making better decisions because of it.
That's what we're aiming for with these deep dives.
It's about giving people the tools to think critically, to ask the right questions, and to navigate this complex world with a bit more awareness and understanding.
Couldn't have said it better myself.
Well, I think we achieved that today.
Me too.
Thanks for joining us on this deep dive into How Complex Systems Fail by Dr. Richard Cook.
It's been a pleasure.
We hope you found it as thought-provoking as we did.
Definitely.
And if you want to learn more, be sure to check out more of Cook's work.
He's a real pioneer in this field.
Absolutely. His insights are more relevant than ever.
I agree.
Until next time.
See you then.